All right, mathletes. So today we're going to talk about transformations of functions, which is section 1.7. Last time we talked about parent functions a little bit. I remember that parent functions are the most basic version of each function, the most fundamental version of each function at its most basic form. And so this is a list of the parent functions that we talked about the other day. And you can see there's all the ones that we saw before: constant, linear, absolute value, quadratic, cubic, square root, reciprocal function. But I've also added a few here, like cube root is a new one that wasn't on the previous slide that I showed you. Exponential, logarithmic, rational. Those are some that you didn't see before. But anyway, just wanted to put this out there, and I'll give you a handout with this on it. And this is just a little more comprehensive version of parent functions. Also, you can see there's trig functions as well. So you can see the sine curve or the sine wave, sometimes called cosine wave. And then you see the tangent function as well. So those are just different parent functions that kind of just add to our mix. Okay. Now, you don't have to memorize all of the parent functions, definitely not the new ones, but it's good to kind of remember roughly what the shapes are and kind of what they look like. Now, with transformations, what we're going to do is we're going to manipulate these basic functions into different versions of the same function. And so instead of having these are all the parents, and with transformations, we can create a family of functions that are similar to the parent functions, but have some different features. And so they might be moved up and down, or left or right, or shifted. They might be stretched vertically or horizontally, or compressed vertically or horizontally, or they might be reflected about the x-axis or about the y-axis, or sometimes about the origin. All right, so I want to start by showing you just what a shift looks like, or a vertical shift. And so basically, we have this function here. You can see it's x cubed, so that's a cubic function, right? And this is the parent function, the most general form. And what I'm going to do is I'm going to keep this f of x function the same, but I'm going to start changing this g of x function. You'll see the changes I make to it and how it changes the graph visually. Okay, so first of all, I'm just going to add 1. So I'm going to just put plus 1 here. And you can see that, as you might imagine, it moved the graph up 1, right? So you can see the red line is the parent function, the blue line is the new function, right? So you can see it shifted up 1. If I change this to a plus 2, you can see now it moves it up 2, right? And you can probably imagine if I put plus 3, it'll move it up 3, plus 5, etc., right? Okay, so if you add something to the outside of a function, on that kind of the outside, and I'll show you the difference between inside and outside in a little bit. But if you add something on the outside to the whole function, then it basically moves it up, right? It's a shift up, or a vertical shift. If I subtract something, you might imagine what's going to happen. It moves it down, right? So if I minus 1, it's going to move it down 1. If I minus 2, it's going to move it down 2. If I minus 5, it's going to move it down 5, and so forth. That's what a vertical shift looks like. You just add or subtract to the outside of a function. All right, now a horizontal shift, what happens is you do something to the inside of the function. So wherever x is, whatever operation is happening with the x, so here we're cubing x. So if you do something inside of that cube, or whatever the operation is, that will have a horizontal effect, okay? So let me add 1 inside here, and let's see what happens. Think about what would happen, and let's see if you're right. So if I add 1, you would maybe think it would go right, but it's actually going to go left, okay? And so that's one thing about the inside, is whatever happens inside is backwards of what you might think, okay? If I add 2, it's actually going to go left 2. If I add 5, it's going to go left 5, and so forth and so on, right? So what do you think happens if I subtract 1? You would think maybe it would go left before we just did that, but it's going to actually go right. Okay, so right 1. If I subtract 2, we're going right 2. If I subtract 5, we're going right 5, etc., etc., right? Okay, and we can do decimals as well, right? Or I can do 1.5, and we go right 1.5. All right. So if we add or subtract, on the outside moves up or down, and positive moves up, negative moves down. If we add or subtract on the inside, it moves left and right. Positive actually moves left, negative moves right. All right, so here's something that captures our what we just learned is these vertical and horizontal shifts, right? So you can see here, vertical shift up, right? If we add a constant on the outside, right? You can see if we subtract a constant on the outside, that's going to be a vertical shift down. And then horizontal shift to the right is if we subtract something on the inside where X is, and then a horizontal shift left is if we add something on the inside, right? Okay, so those are vertical and horizontal shifts. And remember, they happen by adding and subtracting, right? Outside vertical, inside horizontal.